in the window that I am sharing, can I mute anyone?
We are on air now.
Because I am listening to
Hi,
three different
everyone.
voices in my
We are talking to Junior Grossi, who will be talking to us about CQRF.
Oh, good. Good afternoon.
Yep, you can.
Okay. Thank you so much. First of all, I would like to say thank you for this opportunity to speak with you, to you today here. Let me just check how can I, because I am listening my own voice. How can I mute myself for me? Is that possible? Anyone? Can you hear me?
Yeah, we can hear you.
Okay. All right. Okay. All right. All right. So today we are going to be talking about CQRS with event sourcing. I'm going to explain what it is actually, but it's very interesting approach to be used when you need it actually. First, I would like to introduce myself. My name is Junior Grossi. People used to call me just Grossi, my last name. You can find me in the social networks using one of those weird avatars I have. Here you can see my, for example, my Twitter link, GitHub, and my website. That's a bit old, but it's still there. First of all, I am stutterer, so keep calm and let me start that everything is going to be good at the end, I hope. Okay, sometimes it's hard to say, but it works at the end. Okay, so I am the creator of the Corcel project. Corcel is a composer package. It's open source in GitHub. It's a composer package that allows you to use a set of models from the Eloquent ORM from Laravel, who use Laravel is already familiar with it, and with Corcel, you can access the WordPress database using Eloquent models, and you have all the different relationships, etc. So it's very handy if you are working with WordPress and Laravel, for example. Okay. I am also former organizer of the PHPMG user group. We have around 2,000 members, and last year we did an amazing conference in Brazil. I am Brazilian, living in Ireland right now. I love elephants, really love elephants. I am also the creator of the elephant.me website to help you to for example to do for example ratings, and also you can see the ranking in the world. You can see all the different for example, who is the first one, the second one. It's very nice. So if you would like to start your own collection, go to that website. I work for a company called Glofox here in Ireland. We are a remote first company, and we are hiring. We are hiring in Europe, including Russia. So you are very welcome to send your resume to apply. We have people working with PHP, Golang, Java, JavaScript, TypeScript, a lot of different languages to all the different tastes. Okay. Quick overview about my history. I am from Brazil. I have a wife and 2 kids, and since 2004, actually in 2004, when I was doing my bachelor's degree in computer science, on that time, I had an old teacher, an old guy that sometimes said something like this: you have to study, and you have to study a lot, because otherwise you are going to end working with web development. I didn't listen to him, so here I am. I am working mainly with PHP since 2004, so around 16 years. I was running my own company for 9 years, and in 2016 I decided to leave the company and to start working remotely. I worked for United States, the Netherlands, and in 2019 I relocated with my family to Ireland, and here I am. Okay, so let's start. Let's start about talking CQRS and event source. Okay, first I'm going to talk about CQRS first, and after about event source. You can use together, or you can use, for example, independently. It's up to you. Okay. First of all, it's not a software architecture pattern. Okay. You don't have to use it in your whole software, the entire, let's say, for example, the entire project. Okay, it's an independent design pattern, and you can apply only where and when you need it. Right? Where does it fit? First, you don't have to change your current architecture, like I said, and it can be applied to one or more use cases. So it's including that legacy code that you have. We, as PHP engineers, we are used to work with legacy code. We are talking about a language that has 25 years or so, and we have to work with a lot of legacy code, and you also can use CQRS with this legacy code you work with. Okay, it's not a problem. So first, CQRS, it's Command Query Responsibility Segregation. Responsibility segregation is easy to understand, but command query, what it is, it's basically the whole concept is to break the responsibility between reading and writing operations. Okay, so when we are talking about command, we are talking about write operations. When we are talking about query, we say read operations. So write to the database, read from the database. Okay, but why? First of all, scalability, and as a consequence, performance. And we are going to assume that all data might be obsolete ready. So what we are saying is, when you have an application with thousands, millions of users, you cannot say, I am 100% sure that what I am receiving in this endpoint here is exactly what we have in the database, because you can have different replicas, different databases, etc. So it's hard to say that data is real. Okay, and we assume this when talking about CQRS. So if you use Laravel, you are really familiar with this class here. Basically, what we have is, we are creating a user. We have this user controller where we have basically two actions we are creating. So we have the request, the response, and we created the user with everything that we have in the request. We receive a user instance. This is important for the stock, and we are going to return a JSON response with that user and 201 as the response status code. Okay, and we have the show method that's doing. We are querying the database to get the user instance and return the response. So this part here with this part here is very similar with what we have in here and in here. Okay. Okay. In this case, we are using an ORM for a lot of applications, it's the Eloquent ORM, and we use it before and after the database operations. I'm going to explain a bit more later. So how is your database? It's a mess because it has to write, to read, sometimes to write and to read almost at the same time. So it's hard and it's really difficult for the database to manage everything. So what we have in that in that controller example is we have an actor. Let's start from the right side. Okay, we have an actor and we have an HTTP request to register a user. And what we are doing basically is we create a user using the ORM. Okay, and it's happening a lot of funny things, a lot of interesting things inside the ORM to call database to save that user or that information that represents a user in our case. So after we query the database to get the user, we do a lot of different things. Again, we call the ORM, and we have a user instance, a user model, okay? And we return the JSON response. All right, so what is happening here is we have a lot of different things happening, and just to return JSON, okay? So CQRS is event-based, so it's an async communication, okay? And we are going to use a lot here about queues. So we when we have this responsibility segregation, what we are saying is we can use the best of its storage, of its database, for example. So we have in the left side, we have a client and we have the command, or what we are saying, we are going to write, okay? And we call the domain model, etc. And we can use a relational database, in this case, to save this information. And between the relational database and the non-relational database, we have a sync. This sync is event-based. When we add something to the database, we are going to communicate with the non-relational database. Okay, we have a user added here. Please add the same information I have to your database as well. Okay, and we are going to allow queries in the non-relational database. So in this scenario, when we are using CQRS, we are allowing the writing operations in a relational database, and we have the read operations, the queries we have in a non-relational database. Because we can have different, for example, performance in this case, and this is how it works. So we can, for example, decide to use for writing operations MySQL, Postgres, and for reading Elasticsearch, Redis, because we can have, for example, Redis configured at the memory level, so it's going to be blazing fast, really fast, and we don't have to worry with the write operations because we are just reading from a non-relational database. Okay. An important concept that we have here, command handler. So every single time we are talking about CQRS and you read, you listen the word command, what we are saying is we are going to write. It's for writing operations, okay? And we have this concept, I would call it design pattern, to be honest, command handler, okay? What is a command handler design pattern? Is one command for one handler. So if we have register user command, we are going to have register user handler, right? So we use the command for the data, the user data we want to register, and we are going to use the handler for the logic part. Okay, so let's suppose we are creating users in this /v1/users endpoint. It's an API, JSON API, and we have a register user controller. Okay, in here I am already using some PHP 8 features, and so it might be a bit weird for some people, but no worries, you are gonna get the concept. So we have the register user handler, and what we are saying is we have the request, we have the response, we have a single responsibility that's to register the user, and we create the user ID before creating the user. We call the handler, and what we send to the handle method of the handler, we send a command. This command has the user ID, the name, and the email to register the user. And we are going to return a JSON response with only the ID, 201. Okay, but in here we have something very similar with what we had in the other controller example, the Laravel one, the Laravel way, using the ORM, etc. Okay, so just to recap, we have the command for for example, the data, so ID, name, email, etc. And we have only getters, okay? Because if we need to change anything, we need to create another register user command instance. All right, and the handler for the logic, okay? So what is the handler doing actually? We have a user repository, okay, where we are gonna just add a new user, and we are gonna get the user ID from the command, the name and the email from the command as well. We have in here our user entity is for our domain what is the representation of a user. It's not a user model, okay? It could be, but it's more an entity. And we are just adding to the repository. You can see that we are returning nothing here because this is the point of CQRS. I'm gonna explain. So CQRS is event based always. So events don't return data. I'm going to create a user, but I'm not going to return it. It's weird, but yeah. So writing operations in CQRS don't return. What we need to do is what's the user ID? The user ID is 123. Okay, I'm going to return the user ID, and if our front end or our, let's call, for example, our consumer needs more information for that user, we are going to call a different endpoint to get the user when it is available. So, okay, but I'm not going to return the user. Really, you don't need it. You just need the ID, okay? So we can do, we can save the user. Basically, what we are saying in that endpoint is, okay, I know what I have to do. I know that I have to create a user, and I will create it, okay? The user ID will be 1234, okay? And so once it's event based, we can send this handler to the queue. We can use a command bus. What's a command bus in a nutshell? It's a way you are going to receive a command, and we are going to map a command class to a handler class. So we are sending the information, the data, and we are going to add this to the queue. And when it's going to be processed, we already have the data. We are going to create an instance of the handler, and we are going to call that handler with the command, with the data, okay? So what we are saying is, if we are using a command bus, we have the user ID, and we don't have to wait to create the user to return. We can just send this handler to the queue, and we are going to return to the user. So it's going to be really fast. And when we have a chance, we are going to create the user 1-2 seconds later. That is a handler. Let's say, for example, a job that's in the queue to be processed. So the same example that we had, but using a message bus in this case. What we are going to say, we have the same user ID, okay, and we have the same command instance, but instead of calling the handler, we are calling the command bus. Okay, and what we are saying is dispatch these command bus. In this case, it would be synchronous. Okay, so we would have this here happening really fast, and we are going to return the JSON response with the user ID. Probably when the front end, the caller, for example, receives the user ID, when it calls the API to get the user is already created. Probably yes. Okay. And or otherwise, just wait for 1-2 more seconds, and you are going to have this happening behind the scenes. Okay. What about failure? How we handle failures in this case? The queue message, the job, will be processed again when it's possible. Okay, so even if the database is completely, let's say, for example, down, we are going to have a lot of different jobs in the queue waiting to be processed, right? And when we have the database up, we are going to start process one by one. This is a very common, let's say, pattern when we are working with microservices. We use a lot of microservices in the current company I work for, Glofox. We have right now, I'm not sure, but something like 40, 50 different microservices. So in one single request, we have 6, 7 different services being called with sync requests, a sync. It's a lot happening. So what we are saying is our actor, our what I just call it caller, our caller will send the information, the data that I need to register the user. Okay, we have the register user handler. We are gonna add is as a job in the queue, and we are going to return the ID to the actor, so to the caller, and we are going to process this handler when we have resources. So just to explain what is a queue actually in a very few sentences, we have the application, the web application running, and we are going to create different instances of the same application, but running in the command line. Okay, so it's always running. When we add from this application here a handler, job to the queue, we can do other things with the web application, the routes, etc. And we are going to have this other instance of the same application consuming this event. Or same application, or if you are working with microservices, for example, like us, we have different services consuming the same job in the queue, okay? The same event. So when a user is created, we can do a lot of different things in a lot of different services, okay? This is asynchronous communication, okay? All right, so we already talked about the command part, that's the writing operations, and we are going to talk about the query part. Okay, the query is something easier. We have a user finder class, so it's expected if I have a user finder, I'm going to find what? I'm going to find a user. But no, I'm not finding a user. I'm finding an array in this case. It's weird, but I'm going to explain. So we have connection. It's the database connection, for example, the Redis connection, the Elasticsearch connection, etc. And we find one based on the ID, and we have a user data, or it's the information, the data that represents a user for us, but it's not a user entity or a user instance or anything like that. If we don't have a user, we throw an exception, all good, and we are going to return the user data. We are going to return the array. Okay, but why we have, first of all, a connection, and why we are returning an array? Because we don't need a repository or an ORM, because we just need to return JSON at the end. So an array is perfectly fine for what we need to do, okay? So it's faster. Of course, you can do a lot of different things to that information before returning the JSON, yes, but usually is faster, okay? So we don't need a repository. You could use it, but usually it's not required. Where to apply? Microservices using async communication, slow use cases when you need more, for example, performance. So the point is, it's not to apply to every different part of your application, but where you need. For example, a good use case we have is when we are, for example, we have a booking system, and it's happening a lot when you click to confirm the, for example, the booking, okay? Or even if you are using the Uber app, when you request a Uber driver, it's a lot happening, let's say, behind the scenes, and usually is a sync communication, and we asked for a Uber, for example, a driver. But when we have this driver, we are going to be notified. Okay, we are not going to hold the request to the user waiting for searching, etc. Okay. All right, so we already talked about the CQRS part. Now, event sourcing. In event sourcing, everything is an event. Really, everything. State changes are considered events as well. For example, we have a change email handler. We are one more time talking about handlers. Okay. We have a change email handler, so we want to change the user's email address. All right. So in here we have ID 1, name junior, Grossi, email junior@gross.dev. Okay. We have a handle and we have a command, and we want to change the ID. We want to change the email for the user ID number 1. Okay. So in here, I am also using named parameters from PHP 8. It's a new feature. And so what is the issue that we have? What is the for example, let's say the problem? When I access the database, what I have is ID 1, name junior Grossi, email jgross@phpfast.ru. Okay. But what happened? What was my email, let's say, before that? This is the problem that we have. What was the change and what was the reason for that change we had? And we don't have that information. You could check logs, but to be honest, depending on the architecture you have, if you are dealing with microservices, it's hard. It's a lot of different services, a lot of different logs to check. Is a nightmare, to be honest. All right, so what is event sourcing? This is event sourcing. We are recording all the state chains we have. So the first event that happened, user was registered, okay? When and what? User ID 1, name Junior Grossi. This was my email before, and after I have another event, user email was updated. When and what, okay? And in here, I am free to have any payload I want. I can change from email to new email, for example, okay? So why to use the event sourcing? To control state changes, to rewrite history when something bad happens, and we know that shit happens all the time, is and for decision making as well. So we can record all the different events, and we can make decisions based on the behavior the user has or the user had, okay? All events are written in the past. For example, order paid, okay? And we have smaller events here. I'm going to explain the next slide. So we have item added, another item added, item removed, items ordered, order paid, order shipped. A lot of different actions, a lot of different events happening. And we register step by step and all the information, when, what, okay? So some use cases, bug fixes. What happened? You can check in the history what happened that caused that specific, let's say, bug you are trying to fix, okay? And it's an amazing opportunity to use event sourcing for microservices to centralize the histories of all the changes between all the different services. So once it's a sync, you can have separate services just to take care of the event sourcing, let's say, part of the history. So we have a lot of different services firing domain events, sending handlers to the queues, and we have one different service, for example, let's say, consuming that event, and adding all the information, data, when, what, etc. And also when you need to rewrite that base history, it's here, but sometimes you need to, and it's literally travel back in the time to fix something. You can roll, for example, roll back 1 step, 2 steps, 3 steps, 4 steps, or everything, and you can apply everything again because all the step by step was recorded. Event sourcing is part of your domain, okay? So a good advice, you should not use any framework for it. It's part of your domain. You should take care of that logic, okay? If you are, for example, using clean architecture, ports and adapters on your architecture, you know exactly how we should act in terms of not having something from outside impacting our own domain, okay? Just for reference, Proof is a framework. The event source package was deprecated, I think, in the end of 2019, but it's an amazing reference when you need to write your own logic, okay? So keep the domain yours. Use it as a reference only, okay? And we have an important definition when we are talking about event sourcing, that's aggregates. What is an aggregate? It's used to represent what happened. So each event that we have is a state, let's say, change, okay? So we need an aggregate for everything, okay? And these aggregates, they are going to represent the consistency of this state we have. And we are going to ensure that I can change from one state to another. So in here, we are also adding some validations at business level, okay? So what we are saying, for example, a shopping cart always starts empty. I cannot start a shopping cart if we already have a product to it, because it was already started. Another example, what product can be added only if available, okay? The number of items of a product cannot be greater than the stock I have. I want to add 2 caps to the cart, but I have just 1 in stock. I cannot allow this. And it's responsibility to do these validations before moving or before applying this state change, this aggregate, okay? Just a quick example it's a mix of the proof framework and something custom, but we have the concept of a shopping cart, and when we create a shopping cart, we start a new shopping cart session, okay, with this shopping session ID or something, okay? And we have different actions to add a product by the product ID and how many, okay? And we are going to record this here. Every single time you call record, we are adding something. So of course, in this line between this and this here, we need to do some validation. And in here, between this line and this line, of course, we need to do some validation if we can add that product to the cart, okay? More information how they work in the proof documentation is really good as a reference, a very well written code. So a quick review about what we learned is CQRS, different responsibilities between reading and writing operations. Command handler, we are going to have an event being fired, and we can use a command bus to send those handlers, those jobs to a queue to be processed later in a sync processing. And we are going to sync the databases, for example, the MySQL with the Redis one when we have a user added, or for example, user changed the email, etc. We are going to have a sync communication to update everything in the reading database. Event sourcing, register every state change using events. Always, everything is an event when talking about event sourcing. Events plus aggregates. Register the event payload. So always remember, I need a when, I need a what. Okay, when did it happen? What happened? Okay. And we are going to have the history of all the state changes that we had. Okay. Final considerations: don't use CQRS or event sourcing or CQRS and event sourcing in the whole project, in your entire project. Please don't do that. Only use it where you really need. So it's a low endpoint, or you have a very complex logic, and for example, you can move this logic to a sync communication, and if you can do that, because it's going to be so much easier. Okay, how to start? I would say apply CQRS first. It's easier, and start using the command handler pattern. So we are going to extract parts of even your legacy code. You can extract some logic into different handlers. You're going to have a set of handler classes, command and handler classes. And if you want, you can use a message bus to send this handler to be processed later. And you can have this separation between reading and writing operations for that specific use case you need to change or to improve the performance. And event source is amazing, really, but it has a higher learning and a higher implementation curve. So I would say to start from CQRS first, and after it's going to be easier to apply event sourcing when when you know already how to apply the CQRS when you really need it. Always when you really need it. That's all. Thank you so much. I hope you liked it. I have a YouTube channel. I just started it. So if you would like to watch about some design patterns, refactoring, etc., just subscribe. Okay. Thank you so much. Really, thanks.
Hey Grossi, we have a question from the audience on what can we do if we create a job, create a task and cannot run it in the background. Like we have a user with an email that is already registered and we try to register another user and we give that user ID to that new user and the task cannot be completed and the front is asking for the data with the ID that we gave it. So it can keep requesting it forever and the job will not be done.
Okay. We have two different scenarios here. The first one, we could add some validation, let's say, layer. For example, this validation layer would be run before dispatching this handler, this job to the queue. So when we assume that we are gonna send something to be processed, we are already validated and we are 100% sure that this can happen. Okay. Of course, once we are talking about microservices, for example, like I said, we cannot ensure that the data will be 100% available or it is always consistent. For example, I might have validated using the query part. Okay, and in the meantime, when I send this to be processed, later someone else created another user with the same email that was validated. When you have concurrency, this can happen, and this is a valid scenario. And so what I would say is we need to send this job to the queue when we are almost 100% sure that this can be done. And the only reason that this is the, I'd say, for example, the best case scenario, we would not be able to process is if we have some resource that's down or, for example, the queue could not be, for example, processed, or we had another failure. And we need to have some ways to notify the, for example, the user using, for example, WebSockets or, for example, React PHP or anything like that, to notify the user that something happens. Okay, and you have two ways. You are gonna request that user, or after creating it, or you are going to be notified when this user was created using WebSockets, for example. Usually this validation layer is always before processing, and when you are thinking in different layers in the, for example, architecture, you can do that at middleware level. You don't have to deal with it at your controller level. When you arrive in your controller, you are going to assume that you already have the data validated. Okay, that's it. Any other questions?
Okay, good.
Login.
And to continue to follow up on the question, we said that we are pretty sure the task is gonna run successfully, and we have concurrent requests, concurrent queues. imagine we concurrent commands. So imagine we have two of them with to change the same data to different values. And as we run the queue, the first task, the first job, may be down, may be stopped, and run last. So how do we ensure that the last change is actually executed last?
Okay, I'm not sure if I, for example, understood the question exactly. So can you just repeat the last sentence, please? How can I?
So we use the queues, like RabbitMQ, for example,
Okay,
that
sure.
where we put the job in the end of the queue, and some change that had to happen earlier would happen later, and we have data updated on the last event and then on the event before the one. So how can we solve this? How can we?
Okay. First, an important, let's say, topic point is that we are not gonna have always one queue. Depending on the amount of processing of, for example, requests we have, we are going to use different queues for different actions. So, for example, register user, we are going to have a separate queue just for registering users, okay? Or, for example, bookings, etc. It's common when you have concurrence of, for example, booking systems. When you hit let's say for example, the confirmation button doesn't mean that you are gonna have your booking. Okay, for example, you are booking for example, hotel or an airplane ticket. If it's the last one and the other request arrived first, the other one will get the ticket, not you. Okay. And this happens, this is the nature of the concurrency. And what I say is we used to have different queues exactly to know who arrived first, okay? And of course, the example for registering users, it's not a use case that you are going to apply CQRS or event sourcing in the real life. It's a simple use case, but you are going to have different scenarios when you, for example, you are dealing with, let's say, for example, payments, and do a lot of different things. Check the payment provider, etc. And the point is, we are going to notify the user what happened. But we are not going to hold the user request. Okay. Yeah. So have different queues, and you are going to make sure that who arrived first is going to get that resource. Okay.